Okay, so this is going to be a short tutorial on how to quickly visualize LAS files, which is one of the most common LiDAR formats, and then navigate those files as well as make some nice output images that you can share. So basically, the first thing you need to do is download CloudCompare. This is an open source software that I'm sure anyone who's in this world of point clouds and 3D data are already aware of. And if you're not, just do a quick Google search and download whatever the most recent version of the software actually is. Once you have CloudCompare installed, it natively opens all sorts of different formats, file formats. So if we go into this open, we can look at all these different file formats that CloudCompare can handle. Today we're going to be working with LAS files, which are output from a structure from motion based point cloud that was collected with a drone data. So basically, many pictures were collected that have geolocation associated with them. And then we use PhotoScan to align those pictures and create a structure from motion-based point cloud. So we can grab one of these point clouds, which are in this LAS format, and just click open. Once we have this, we can just go with the defaults for all of this, hit apply, and then this particular part of the import is to get rid of these really large coordinates that are from the points being in UTM coordinate system. So we just hit yes for this. If we wanted to make sure that this shift is stored, well, CloudCompare actually does that for us, which is really nice. It does this shift partially to keep the precision of the points in the point cloud. So we can hit yes, and it's going to take a second to open this LAS file because it's really big. This is covering a 10-hectare area, and within the 10-hectare area, we're mostly getting points in the point cloud that are associated with a canopy, but it's extremely dense. And so we have around 154 million individual points associated with this point cloud. And so once this finally opens up, we'll be able to do a few basic things in CloudCompare that I can show you that are really interesting and pretty useful for kind of teasing apart and looking at the different details within your point cloud. So we'll wait for this to finish, and hopefully it will load up and not crash my computer. Rainbow wheel. There we are. Okay, so as soon as this comes in, it's going to be one continuous color. Part of the reason is because if we click on this file in our excuse me, hierarchical menu, we're going to see that we can select multiple different pieces of information to display that are associated with each point. So in this case, in just about any LAS file, there will be a point source ID, so there's IDs associated with individual points. Scan direction, intensity, all these things, if this were real LiDAR data, which it is not, it's structure from motion data, all of these would be filled in with information that was based on the the scanner and the aircraft, basically aircraft position. Intensity is something that we can use to look at the point cloud, but again, this is not true intensity. This is based on the imagery that was collected with the drone. So we can potentially use it for something interesting, but in this case, we're gonna ignore the intensity and all the other values. And then what we're going to do is we're going to pull in the spatial data that describes the height above a certain point. And to do that, we go into Edit, Scalar Fields, and then Export Coordinates to Scalar Fields. And the Z is just, these are the heights. So if we want to visualize what the height estimates are across the canopy, we do this and then we hit OK. And once we do this, we get something that you would expect to see with a canopy height map from airborne LiDAR. The one problem with this, though, is that it is not color blind friendly. So let's change it to Viridis because Viridis is great. And we can adjust this little slider here to get the dark values nice, and then adjust this upper saturation slider to get these the high values kind of more honed in. So if we want to actually start exploring this, we can use the scroll or the slide if you're working with a touchpad and zoom in and start looking at it. This particular drone point cloud was capturing an area over a flux tower, which you can actually see in this point cloud, which I find to be amazing. One of the useful things you can do in CloudCompare is if you want to center on an object, you can click this Pick Rotation Center button. So click that, and then click a point in the point cloud. And once it thinks for a second, it tells you it's picked that as its rotation center, and then you can rotate, and that is mainly what you're going to be rotating around. So you can start to see as the canopy kind of fills in there that we're able to really get a good look at what we collected. So this is really cool because this is basically a canopy height model made with a $1,000 drone, and then you know much more in licensing for the processing software. But that said, this is just about as cheap as you can get for collecting your own structural data in forests with a drone. So the next thing I was going to show is how to make some visualizations and how to pull out some profiles from this type of data in CloudCompare. So one of the things you can do is you can use these little clipping tools, the segment scissors, and if you click that, you can isolate individual areas of the point cloud. So we can click around like this, and when you're done with it, you right click, and then you would segment in with this bright red polygon here. But for what I want to do today, after that you would hit the check mark to finish that segmentation. But what I want to do today is show you how to create a transect, so you can kind of see the way that structure from motion data is actually being captured and what it's giving you, since you're going to miss a good portion of the interior of the canopy. But what we can do is we can grab this cross-section tool. And this is nice because it keeps the original point cloud all in one, all together. So once I click that, it's going to come with a little box right here, and then we'll have some arrows that we can maneuver around and estimate kind of the area that we want to subset. So it's taking its time. Ooh, yeah, my computer's humming away. While we're waiting for that, we can just use the segment tool, because maybe that one's working and this one's having issues because the screen recording. So anyway, we can create a transect with this segment tool as well. So you basically want to unpause, make sure that you're able to select a certain area, and then I'll take a little transect across like kind of a small topographic gradient here. So we're going to create this little green line, and I'm going to include the tower here in our transect or segmentation. Create something that looks kind of like a box, and then right click, and then again hit this segment in button. It's going to think for a second, but then everything else around here will disappear and we'll be left with what's inside the box. There we go. We're going to hit check, and then once we hit that check, we'll have two separate point clouds. One that is this inner segmentation and the other that's the outer segmentation. So now what we can do is we can click our little zoom magnifying glass, zoom into our area, and let's pick another rotation point right in the center of this point cloud. And when this comes up, we can just hit yes, because this makes moving the point cloud a little smoother. And we can turn on the side and actually see what the structure of this data actually looks like. So this is kind of cool. You can see the type of canopy structure that you're actually capturing with structure from motion. You can see these canopy gaps. You can see the texture of the these what are mostly deciduous trees in Virginia, but really the different heights and everything are coming through nicely. And again, you can see this little gap around where this flex tower is. So if we wanted to visualize this and impress people with really cool looking structure from motion drone visualizations, one of the things that you can do is you can turn a couple different filters on specifically for visualization. One is this eye dome lighting, EDL, on the right. If you turn this filter on, you can artificially add depth to the point cloud, and this is cool because you can really start to pull out the structure of these surfaces, because there are these black outlines that are kind of added to this, which really kind of clear up this whole canopy structure, which is really nice. So if we wanted to visualize this picture right here, so let's use this as our example kind of frame. What we would do is go into the menu of CloudCompare where we have display. On my computer, I'm clicking the display menu. This screen capture is not getting that full thing, but click display and go down to render to file. And so what I'm going to do is I'm going to create an image based on the window within CloudCompare. And so we'll just name it test transect. And one of the ways that you can make these images look really nice is by increasing the zoom level, because that'll start oversampling the points and gives it kind of a nice semi-transparent look. So this will be our test with eye dome lighting, EDL, and then I'm going to hit OK, and then we can try to actually look at what that turned out as. Oh yeah, wow. So that's really cool. And the thing too is when you oversample like that, you're actually getting a good bit of the detail in this. So it is a really effective way of creating a really nice looking image of your point cloud. So if we go back to CloudCompare, one of the other things that's kind of useful and more quantitative that we can do with this is start looking at the height distribution in different areas of the forest. So say maybe we want to segment one more time and look at the height distribution of, I don't know, let's say one of these little canopy clusters. So we'll segment, do our segment tool, and we can just segment around a little area in the forest, and we can pretend like this is a fake forest plot. Segment in, confirm segmentation, and again we have a nice little structure of the canopy. This is not exactly like LiDAR data because we're not getting a whole lot of the understory or anything, but what we can then do is we can look at the distribution of heights with a nice little histogram. So this gives you kind of a rough idea of what the vegetation structure looks like. And we can, basically say that this is approximately ground level, or and this is the distribution of vegetation throughout the canopy. This has not been adjusted to a DEM. So anyway, so that's basically that's kind of what I go through, regardless of the type of 3D data that I'm working with, to create some nice looking pictures and visualizations. And I'll create one more that we can look at here with this little segmentation, render to file, and test one. And this one's not going to have the eye dome lighting, so you can maybe see the difference there. Very, very different kind of look. And we're also closer to the point cloud. So if you're really close to the point cloud, you can increase the point size, and then again we can turn on the eye dome lighting, render to file again, can retry it, see what happens. Ooh, looks a little different. That's pretty cool. Anyway, that is that's pretty much it. Let me know if you have any questions, and hopefully this was helpful to some people who are working with these type of data. All right, bye-bye.